Hi, I'm Mike Chipoller, Product Manager at Airline. Today we'll be discussing predictive maintenance options from Omron so you can stop running in reactive maintenance mode. I have Luke Miller, Account Manager from Omron, with me to help explain predictive maintenance options. Luke?
Yeah, hi, thanks Mike. Today we'd like to introduce you to a new line of Omron products that are specifically designed towards equipment condition monitoring and abnormality detection. We call that predictive maintenance. Predictive maintenance is designed towards automating the measurement process of equipment to notify the user of abnormalities that may have the potential to cause unplanned downtime that costs you money. We have 6 products in this line, and we're going to show you today exactly how powerful they can be and how valuable they can be for your plant. The S8VK-X is one of our most advanced power supplies that we offer. The first step in scheduled maintenance is knowing when to replace your power supply. The S8VK-X calculates the deterioration of the internal electrolytic capacitor based on its component's temperature. This way it knows exactly how many years it has left and exactly the remaining lifetime percentage of the device. And that's all viewable via the on-unit display.
It also monitors output voltage and current, critical metrics in optimizing the lifetime of any power supply.
Yeah, and the smartest thing about this power supply is the integrated Ethernet IP communications, which allow you to monitor those metrics remotely when connected to a PC, PLC, or machine automation controller. But this is where it gets pretty interesting. You can set the maximum output current, and if that threshold is surpassed, an alarm will trigger. Let's take a look at my system. I have a motor that's powered by my S8VK-X. Let's say I need this motor spinning at exactly this speed. Now check out the real-time data on the software. My output current amps are around 0.3. With that number in mind, I'm going to set my output current to 0.4, so that's the threshold, the highest threshold. Now for whatever reason, maybe there's some debris caught in a conveyor belt or an operator made a mistake, but for some reason, my motor starts drawing more power. An alarm has been triggered, which can then notify a remote maintenance person that there's some issue with the machinery and that this power supply is running that machine. So now I've fixed the problem and I need to hold the button on the unit to reset.
Now we're able to catch the machine failure before it causes downstream problems, and we're optimizing the power supply's lifetime but not overdrawing current.
Next in our predictive maintenance lineup is the K6PM, a thermal condition monitor. The number of devices in your typical control panel has increased significantly over the years, and at the same time, it's getting harder and harder for plant managers to find and keep maintenance personnel. This means it's all too common for components to fail.
Failures like transformer heat generation, insulation breakdown, filter line damage, inverter overload, and loose connections to high voltage contactors can be costly and dangerous.
Our solution to this dilemma is the K6PM. Using one or more mounted infrared sensors, it accurately reads temperature information in real time. Then based on your predetermined temperature thresholds, it triggers one of 3 alarms: normal, caution, or warning, and sends that information to a PC or PLC via Ethernet IP or Modbus TCP.
When connected to a PC with the included software, you can set the temperature thresholds for each thermal sensor. This is also where you see their live temperature data and thermal images.
Moving on in today's showcase, we have the K6CM series 3-phase induction motor condition monitors. So traditional 3-phase motors are complicated, costly, and time-consuming to maintain. Normally an engineer has to use lived experience to catch issues like bearing wear, insulation degradation, rotary shaft abnormalities, overload, and/or pump cavitation. The K6CM, CIM, ISM, and VB detect key symptoms of these phenomena as they happen. That way, maintenance personnel knows exactly where they're needed without the guesswork.
Just like we covered earlier in other devices, the communication through Ethernet IP, Modbus TCP to a PLC or PC are so critical so information can be seen remotely.
Let's break down how each of these work. The K6CM CIM uses a clamp type current transformer to read the motor's current waveform. Changes in the waveform can indicate load irregularities, cavitation, or misalignment. The K6CM ISM uses a clamp type 0-phase current transformer to monitor leakage current at the secondary side of an inverter. Fluctuating leakage current is an indication of motor insulation deterioration. The K6CM VB uses a vibration and temperature sensor to monitor the bearing of a motor. Increased bearing vibration or heat could indicate a lack of grease, damage, or breakdown. Now we'll demonstrate the K6CM VB with our motor from earlier.
And note, the sensor can be mounted to the motor utilizing either a magnetic mount or direct mount.
Alrighty, so now I'm going to get into the live demonstration of the K6CM motor condition monitor. Here we have our sensor, which is actually a magnetic vibration and heat sensor. I'm going to leave that on the motor. And we have our motor. So this is, let's say our working system has a motor vibration in G's of, 0.1 to 0.15 G's. And you can also see that in my real-time information that's linked to a server on the software. So everything's going right, but let's say there's some issue with the motor where it causes some vibration, extra vibration that could potentially damage the motor or the systems downstream. I'm going to simulate that now. So I've set thresholds for 0.4 to tell me, 0.4 G's to tell me there's something gone wrong. So you see now I have a yellow indication telling me there's a warning, something has gone slightly wrong. Now let's say something's gone catastrophic. I've set that for 0.5 G's. So now something's gone wrong. You can see in my real-time software that there's an issue. There's a critical alarm that's been tripped, and the only thing that can be done to turn that off is with maintenance personnel going in and pressing the alarm reset button. Now you'd know right away when something's gone awry, and we can fix an issue before it causes unplanned downtime.
Okay, so the K6CM series is actually the perfect solution to monitor your three-phase motors.
To finish off today's predictive maintenance showcase, we'll touch on the K7GE motor insulation resistance monitor. While the K6CM series can monitor three-phase induction motors with various sensors, the K7GE specializes in insulation resistance monitoring for servo, single-phase, and three-phase motors. Motor insulation degradation is caused by contamination, vibration, thermal aging, and overvoltage spikes. Then we see electric leakage at the back end of the motor, which causes electric shock, fires, and equipment failure.
And that's why it's routine for maintenance teams to perform manual meter readings and inspections for every motor in the plant several times a year.
And this is where the K7GE comes in. A single unit can monitor that electricity leakage of up to 8 motors to catch insulation degradation as soon as possible. It will then relay that information through an RS-485 connection to a PLC, serial IF gateway, or HMI to alert maintenance teams to the issue. Those alarm thresholds can be configured on a connected PC through an Excel-based software tool. And just like that, one device reduces the chance of unplanned downtime due to motor failure and lowers maintenance costs.
Luke, thank you again for a lot of great information on what Omron has for predictive maintenance. If you liked the video, please give us a thumbs up and hit the subscribe button, and keep an eye out for more predictive maintenance videos coming in the future. Thank you.